Okay, so without much delay, I'm going to start. Last day, we have just started the glimpses of relations. So I'll again keep a short recap of that so that we can understand it better. Okay, so relation. Of course, we have some problems to be done for your Cartesian product that will do after I finish the relation part. So we have started with relation. So what was the definition? It is any subset R of A cross B where A and B are two non-empty set, right, is called a relation on A to B, right? That is R is a subset of A cross B. This is what we got last day, right? So now we can have a note here. Last day I noted it also. Notice that if this subset R is phi, R is called the empty relation or null relation or void relation on A to B. And if in case R is the complete Cartesian product, R is called universal relation. Universal relation. So these two are the very important notes which we must be knowing. We should know this. And this is what we should know. This is a very important note. We should always remember. Right? Now next, note number 3, I'll include here. See, a number of elements in A cross B is number of elements in A into number of elements in B. This already we got. Also, number of subsets of A cross B. What will it be? It is 2 to the power n of A cross B. So that I can write as 2 to the power n of A into n of B. So as we have said that any subset R of AB, right, is called a relation on AB. So very clearly, all these twice n 2 to the power n A into nb, these sets, all subsets of A cross B are forming a relation, one relation from A to B. So from here very easily we can conclude number of relation from A to B is equal to 2 to the power n of A cross B. So this is the another important thing you should always remember. Always you should remember because this is very important point. Very important point. Okay. So please kindly note it once you finish it. Inform me. Okay. So I'm going to the next board. I'm going to the next board and I'll be first taking 1-2 examples and then I'll be representing it. Ways of I'm coming to the representation of this relations in various forms. Example I want to take. Say I want to consider the set A as 1, 2, 3 and B as say 2, 3, 4. Right now I want to define a relation. Relation, as I told you last day in the last class, that it is of the form A comma B, where A and B must be like taken from respective sets. And at the same time, there is a condition. If you remember, I wrote last day that there is a condition to be mentioned here, which will tell you how to relate A and B. So here I'll say A divides B. My condition is this system, right? My condition is this. This is the relation, and this is my condition. A divides B, right? If A will divide B, then I say that A and B are related. Now we will be going to write the whole relation first with the help of a figure, right? We'll be having many different representations, right? I'll be first writing with the figure because figure is the part where it is always comfortable for us to denote, depict the things. So I'm considering a figure here for your convenience, and not for only your convenience, it is very convenient for explanation as well. So here what exactly I'm going to consider, this is the set A, this is the set A, and this is the set B. So we have considered this is a set A and B, right? So these are the two sets. Then we would like to consider the elements here. Elements here are, it is 1, then we'll be having elements 2, we'll be having elements here 3. These are 3 elements. Here element is 2, here element is 3, here element is 4. These are the elements we have got. So now just remember one thing. This particular set is giving you the element A here, and this particular set is giving you the element B. And the condition tells A divides B. That means these numbers should divide these numbers, whoever are dividing. And it is not necessary that everyone should divide. Now, whoever is dividing, we can say that they are related. So now our task is to find that. So just you try to see 1 is a factor of every number. That means 1 is going to divide 2. So I draw an arrowhead. Then 1 is 1 is again going to divide 3. 1 is again going to divide 4. Right? So that means 1 will be related to each and every other element of the set B. See, at the same time, I'm going to note down something here. The relation in the Cartesian, roster form. So it is 1 comma 2 I can write, then 1 comma 3 I can write, 1 comma 4 I can write. This is the first set where we got. Next, we would like to now write, we want to take the set A and choose element 2. So 2 will be dividing whom? 2. Okay, fine. 2 is dividing 2. That's great. Now, is 2 dividing 3? No, it is not dividing. So 2 will not be related to 3. It means there will be no arrowhead going out from 2 to 3. But it divides 4. So there will be arrowhead going from 2 to 4. So after that, immediately you can fill this that 2 comma 2 is related, 2 comma 4 is related. Right? Now you again come back to the third element. In the third element, 3. 3 is dividing only one element, 3, because it is not a factor of any other element. So what is the third element where I should write here? It is 3 comma 3. So once you do this, you have completed two different representation here. Please observe that. One representation which I am writing in a box, that is in the roster form, roster form or tabulation form. This is one way of representation. This is already given. This is the rule method or set builder method. Now this is what we used is called arrow diagram, right? Arrow diagram. So we have these three methods very clearly to represent the relations. But apart from this, we have one more method, two more methods. I'll explain that also. But before that, I want to say that always you should indicate it like this, and the name of the relation should be written here. So this is the actual representation what we do to represent a relation in arrow diagram. Till here, is it clear, Swarnav? Okay. Now you see, before I go for the next representation, had it been A cross B, you would have got arrows coming out from each and every element to each and every element of the other set. Like from 1, it is coming from 1 to all the three elements. But because it is not A cross B, it is just a subset, or that subset is satisfying this condition. So it is sometimes maybe possible that elements of this set may not be giving out any arrowhead from this place, indicating that maybe there will be some elements which will not be related to any element of the set B. It may be possible. Here, what do we find? All elements are related to something, but like 3 is not related to 4 and 2. It may be also possible in case of relation when we give conditions. But A cross B, if you find, you have to draw arrowheads from every element of set A to each and every element of set B. That is the difference. So now we are going to represent this particular set in a very different way. We call it the day last day I have represented the relation, cross product, Cartesian product, right, in coordinate plane, right, which we call actually I am writing coordinate plane, right? In coordinate plane will be representing it is or rather we can say graphically, right? And if you need a good name, we call it lattice, right? We call it lattice. It is a lattice representation. So in lattice representation, what we do, it's nothing but representation of this relation in the coordinate plane, right? So here, as I have only these numbers elements, so there is no problem. So first, I'm going to represent all the elements here. So all are positive. So we represent here. Say this is 1, this is 2, this is 3, and here I need 1, 2, 3. Little more will be needed. Little bigger I need. So I bring it little up. Okay. So here it is 4. So now I'm going to relate the points. See, the first 3 points. The first 3 points. 1, 2. 1 from this horizontal line and 2 from the vertical line. This is the process you follow. This is one of the element, first element. Then is 1, 3. 1, 3. This is the element. Then 1, 4. This is the element. Next element is 2, 2, 2, then here it is 2, and then 2 is related to 4. And the last element is, and the last element is your 3, 3. So it will be here. So unlike to your Cartesian product, this particular grid will have some gaps between. This particular grid will have some gap between because all elements are not related to every other element, right? So this is the part which represents your relation. You should not square it as I did. I just wanted to emphasize because of that. Because of that, I have squared it, right? Like this. You should not square it. It is for your understanding I have written. So this is one of the way, right? If you draw graph, then it will be very, very clear. In graph paper, these points will be exactly located without any mistake. Have you understood? Sure, no. Okay. I'll go to the next board in order to represent the next process. Next process is again important one. This is the fifth one where we use matrix, right? We use matrix representation. In a matrix, we can represent this. So how do we do it? Just see in matrix representation, right? So when it is matrix representation, you check first elements in set A, number of elements in set A, and number of elements in set B. Number of elements in set A is 3, and of course it is a coincidence that I have considered 3, right? So whatever may be the number of elements, that doesn't affect. Only thing is that whenever you are considering number of elements in A set, one more than that row you have to construct in the matrix, and whatever is the element in set B, one more than that number of columns you have to form in the matrix. Now I'm going to do it will be ultimately 4 by 4, 4 rows and 4 columns, right? One more why we need, you will come to know. So now you see we are going to construct matrices. 4 by 4 I need. So I have divided this into 4 rows, and then we have divided this into 4 columns, right? It is a representation, so it is not necessary that your division should be exactly alike, not like this, right? So we have drawn this, right? So we have got this matrix. Now we are in the way to represent, right? So here actually, here we write this way. Down way we represent A, and this way we represent the elements of B. And then we have to write the elements of set A and set B. So A having value what? What is the elements of set A? Can you remember it is 1, 2, 3. So you write 1, 2, 3 here. And what is the set B? It is 2, 3, 4. So these elements you write along this row 2, 3, 4. Okay. Now you come to the main part. What exactly is the process of representation? What we should do now? Okay, till here it is clear, I think. So what we do here, you try to remember this. You have to understand in this representation what we do. This is very important. If A and B are related, we consider one in the table actually, in the matrix table. How I'll write that I'll tell you. And if they are not related, we consider 0. So 1 and 0 is the only these two binary digits will be using. Now how will you use this? You will take first the elements from here and then corresponding elements here. Say 1 you have taken and you have chosen 2. 1 and 2. This is A, this is B. Now, do you have 1 related to B? What is the relation? These numbers should divide this. If it is like this, then the 2 will be related. So once 1 is related to 2, I should write value as 1. But where will we write? So for that, what we do, we draw, right? We draw a virtual line through 1 horizontally and through 2 another horizontal vertical line virtually. So where will these two lines intersect? In this particular cell, in this particular cell, in this particular cell. So in this particular cell, you have to write the value. So 1 and 2 are related, so I'll write 1 here. In the same go, 1 and 3 are related, so I'll write 1 here. 1 and 4 are related, I'll write 1 here. Now, once you finish with 1, you come to 2. 2 and 2 are related, so it will be 1. 2 and 3 are related or not? They are not related, so 0. 2 and 4 are related, it is 1. 3 and 2 related? No. 3 and 3 related? Yes. 3 and 4 related? No. So this is what the matrix representation. This is what the matrix representation. Please try to understand that. Have you understood? So these are the 5 ways of representation, right? Total, you have 5 ways of representing a relation. One is the roster form. Two, it is the set builder form. Number three, from diagrammatic approach, it is arrow diagram. Number four, lattice, or you can say um, this coordinate plane, and last one is the matrix. So these 5 are the ways of representation of a relation with the help of either algebraic expressions or your diagrammatic expressions. Have you finished? Okay, so thank you. I'll now go for defining a very important concept, that is the domain and range of a relation, right? Domain, range, and codomain. These are the things we are going to represent now. I'm going to represent this. First, again, as I told you, the figures are the most suitable one. So I'll first take a figure so that it will be comfortable for you to understand this, right? First, I'll draw a figure. This time, I'll do it in such a way that you'll be getting all possibilities here. That is, some elements may be related, some elements may not be related, so that we get a good concept of a representation of domain and range very, very clearly without any problem. So this time I do not want to name any elements here as ABC. I just say that there is a relation R from the set, say set name I'll give. This is the set, say A, right? And then suppose this is the set B. So from A to B there is a relation R. And we have certain elements. Now that elements I do not want to name this time. Rather, just I would like to write some thoughts for the representation of elements, right? So these are the elements of this set, and here also similarly some elements are there like this. Now suppose there is a relation. Presently I do not bother about a condition, what conditions relate them. I only know that there is a relation which relates this element to this, suppose, and this element is related to this element. This is related here because of some conditions, right? So I don't know the conditions, no need to know it. And suppose then this element is related to this, then this element again is related to this, and this same element is suppose related to this as well. It is not at all necessary that you should have some repeated representations. It is not necessary. But I did. And suppose this is having a relation with this. And then you have another relation of elements. So this element is related to this. So this is the representation. This is the representation for the get. Okay. So now observe very, very carefully. Very carefully. Now I'm going to make very clear observations, and that you should be very, very clear. After this, obviously, you already got to know how to relate them in the set builder method or roster method, whatever it is given. Now you see, I would like to name these elements. Suppose A, B, C, D, E, F, this is G, H, and these suppose 1, 2. 3, 4, 5, 6, 7, 8, 9. Now clearly observation says that all elements of the set is not related to some of the elements of this. And similarly, this set also contains few elements which doesn't have any related to this set, right? So whenever you find such situations in a relation, then now you can go on constructing a set in which you will include the elements. See, I want to just write a complicated structure here, avoiding other elements. I have included only one element, sorry, only those elements which are somehow related, to the elements of the other set. This particular set, of course, this shape is not impressive, but anyway, that is not an issue. This particular set is known as the domain, right? So what did you observe? Domain means that particular set of consisting of elements which are having some relative. Just say 1 is having a relative, so 1 is included in the domain. C is having some relatives, maybe more than 1, maybe 1 also invented it, so it will be included in the domain. And then similarly, you should construct a set in this side also of those elements which are having a relation with the left side set. You have to avoid those elements, like here, see, I have avoided 5, 6, even 8 I have avoided, right? So you have to avoid this. And once you avoid this, then this particular set is known as the range of the relation, RANZE, range of the relation. Yes, sure enough, till now it is clear. Okay, and then this the whole set, right hand side whole set, this is known as the codomain. Codomain. This is known as the codomain. So this is all about our representation. This is all of our representations, right? So now you see, this is, so I have told you the name. Now by chance somebody wants you to write the domain. So domain will be what? It is equal to this domain. I have written the name here. Domain will be equal to, here it is A, element A is related, then B was not related, C is related, then E is related, and Z is related. So in the set will, in your roster method, which elements will come? A will come in the domain, C will come in the domain, E will be coming, and Z will be coming. And in the same way, if you would like to write the
Sir,
range.
you have written B instead of
Oh,
A.
sorry. Thank you. Thank you for identifying. Thank you. Thank you. Thank you so much. I, by mistake, wrote this as element B. Just a minute. I'll correct. I'll correct. Thank you so much. It should be C. Yes. I read out at C, but I did not write it as C. So now here in the range, what will come? In the range, you will be getting 1 is related, so 1 will come. 2 is related, 2 will be coming. 3 related, 3 will be coming. 4 will be coming. Then 5 and 6 will not come. 7 will come. 8 will not come. And 9 will come. So these are the elements which will be constituting the range. So this is what is the thing. And as far as the codomain is concerned, codomain will contain all the elements. Codomain will contain all the elements, right? In the right hand side, 1, comma 2, comma 3, comma. As I know that all elements will be there, I am using dot here, right? Because in the same pattern you can move. So this is the codomain. So this is the idea how we generate the domain, codomain, and range in the figure. Right, from the figure it is visualized. Now this we have to convert definitely into analytical way, right? So that also I am proceeding now. But before I proceed further, I just want to talk about the symbol. Domain can be represented in either you write dom R if the name of the relation is R, or you may be using symbol the capital D suffix R. Range can be written as range of bracket R. Sometimes we write R for range and suffix R for the relation, but that is confusing. So less number of times we use. Codomain can be written as codom R or COD cod R bracket you can use, and otherwise CDR. So these symbols we can use for representation of codomains. Okay, fine. So now, okay. So now, next, whenever you observe, you can have now a scope to write the whole relation R in the form of ordered pair. So how you write the ordered pairs? With A, your relation is with 1. This is 1. With A, you have a relation with whom? What ordered pair will come? With A, then there is a 7 related. Then you can write a comma. And then with C, there is no element related to B. With C, there are three elements. It is 2, then 4, and 7. So C comma 2, then C comma 7, and then, okay, I missed one, no problem. That I'll write here. C comma 4, this is here. And now a few more are there that also we have to write when you read the relation in the roster form. So I extended this, and then now this is E comma, E is related to 3, E is related to only 1, and then Z is related to 9. So once you finish it, close the bracket. So this is the representation of the whole relation in what form? This is the roster form. Acha, I already explained you all the things, and then suddenly I brought this again. Why? There is a reason. The reason is that there is a relation between the elements of the domain and this whole representation. So you should know elements of domain will be reflected where. See, elements of domain, that is the elements which are having some relative, are reflected in the first place of the order pairs. You can notice, right? Those elements which are in the first place of the ordered pair, they are actually exclusively the elements of the domain. And if any element is not coming in the first place of the ordered pairs, it is very sure that they will not be belonging to the domain. So you can see here, you will not find anywhere the element B in the first place, and so domain is not containing B. So what we mean to say is that when you represent the relation in the roster form, the set of all the first place element constitute the domain, and second place element constitute the range. And of course, codomain impression you will not get from this particular representation. That too you have to see originally from which particular set to what set they have represented the relation. So I'll be going to write a note after this in the next page. If you finish, please inform me. Okay, so now one more thing I just want to ask you. Am I explaining very slowly, or I should go with this pace only? If you say I can increase my speed.
Sir, you can go with this. Sir.
Okay, take it. You are not feeling bored, right?
No, sir.
Okay, thank you. So now I'm going to write the note. That note is very, very important. Note in a roster form, right? The set of all elements in the first place of ordered pairs. Rather, we can say first component, right? Both the words are valid. First components of ordered pairs, right? Constitute the domain. This is for the domain. The second elements set is called the of the relation. Range of the relation. So these two are the things which always you should remember when a relation is represented in fact in set roster form. So this is what is the conclusion of what I explained so far. And now we'll be proceeding for doing certain problems. Then it will be easy for us to understand that. And then we'll be doing some very, very important questions what I left for Cartesian product, which are very, very important for concept growth, right? Anyway, now I'm doing some of the important questions so that you will be comfortable, right? Of course, we'll be having type of relations. So actually, Swarnav, let me try to tell you, I'm going to cover both 11 and 12 syllabus. Some extension of this relation is there in 12. So I'll finish it so that you can prepare for a very good, strong competitive exams. Okay. So I'm going to start now with questions. Question number one. So what exactly we'll be having? You see, here my question is, there is a set containing elements 1, 2, 3, and another set B is there. This bracket is only once, right? This is not there. Then 4, 5, 6. These are the elements of the set, other set, right? So then after that, we have to justify which of the following are relations from A to B. So this is one of the set here. So first I'll write this and then one by one we'll be going for explanation. Number two, I'll write this is 1 comma 5, then 2 comma 6, 3 comma 4, and then 3 comma 6. Third one is 4 comma 2, and then 4 comma 3, 5 comma 1, and one more we'll write. Okay, it is A cross B. Now we have to justify one by one whether they are relations on A to B or not. If so, why? That we have to write. So for being relation, whatever we get, this must be a subset of A cross B. By the meaning subset, what I must say, every element of this must be in A cross B. That means each of the ordered pair must belong to A cross B. That means first element must belong to the first set, second element must belong to the second set. So that is the criteria you observe. If it is satisfying, it's well and good. So for that, you just check whether every first place element is found in the set A or not. So in the very first set, you will find that this 5 is not in the set A. This 5 is not in the set A. So if that 5 is not in the set A, so what I can say, 5 comma 2 does not belong to A cross B. So this particular part is not a subset of A cross B. Therefore, it is not a relation. It is not a relation on A to B. Remember it. If you simply say it is not a relation, it is not a good answer. It is not a relation. Why it is not a relation? It can be a relation from another set to this other set, right? It is not a relation from this above seed set. So you must be very, very clear about that. Okay. So this is one we did. Secondly, you see one element is here. Two is also belonging to this. Three belongs to this. Three belongs to this. Fine. All elements of the first place are from A. Then second place element contains 5. It is found here. 6 is also found here. 4 and 6 both are found here. Excellent. This time what we can say? All the elements, each and every elements will be belonging to A cross B and will imply that this is a subset of A cross B. And this will imply what? It is a relation on A to B. Done. Right? So now make sure for the next set. 4. Oh, 4 cannot be found here. Right? In fact, one more element, 2. In fact, all the first place elements are not belonging to the set A. Right? This 4 is not belonging. This 4 is not belonging. This 4 is not belonging. So it is useless to see the next. So obviously, what will happen? This is not a subset of A cross B. So if it is not a subset of A cross B, it is not a relation on A to B. That's it. That's it. And at last two usually you can identify because A cross B itself is a relation. So he got it. This name was very unique. It was what? It is called a universal relation because whole A cross B has been considered. Right? So I do hope that you have understood this. Right? So if you have any queries, then ask me. Or else if you have finished, you can indicate me. Finished. Okay, great. So I'm going for the next question. I'll be picking up the next question. Question number 2 here. So now let us see what is the question here. I want to define the relation R. R. R is defined. A relation R is defined. I am writing in a short way. R is defined on A. What is the set A? It contains element 2, 3, 4, and 5. To set B, it is containing 3, 6, 7, and 10. Such that, such that I would say X and Y will be related. That means X comma Y will belong to R if X is relatively prime to Y. Prime to Y. Okay, somebody might speak it like this also. Right? Instead of saying X is relatively prime to Y, they can say X, Y are relatively prime, or maybe they are having another representation X, Y are O prime. Right? So all these can be used for the explanation. So this is the condition. Now you have to find first the roster representation, and then what is a domain, and what is a range, and what is a codomain. Right? So they are asking for the roster representation. So we are going to first represent the roster. So it is the solution R. Okay, you pick elements of set A first. 2. 2 is related to other elements means 2 and that element must be relatively prime. And relatively prime means what? HCF is 1. That means they do not have any factor other than 1 in common. So 2 is having any factor common with 3? No. So 2 is related to 3. So I can write a order pair 2, 3 here. Then 3, 2, with 2 you check other elements. 2, right? I'm using the cursor here. 2 and 6 I cannot put because they have factors in common. 2 comma 7 will be here, whereas 2 comma 10 will not be there because 2 will be a factor of 10. So they will not be relative. So what will be there? 2 comma 3 and 2 comma 7. Similarly, if I start with 3 for the set A, now do not get confused. I did not take this 3 in the first place. I have taken 3 from the first set. So 3 is related to whom? 7, and 3 is related to, sorry, this should have been 10. I wrote 7. This is 10 because 3 does not divide 10. So it has HF 1 with 10. So after finishing with 3, what you can write? 4, then order pair 3 will come, then 4, and then what will come? 7. Acha. Then 4, will it come with 10? No. 4 and 10 will not come because HF is not 1. It has common factor other than HF, 1, right? They are not relatively fair. So 4 comma 10 will not come. Now you take 5. 5, yes, it can be paired with 3. Very nice. And then 5 can be paired with 7. No more. So this is what we have written now, and we finish it. And this is the required
Sir, 5 with 6
5.
with
Oh,
6.
5 and 6. 5 and 6. Right, right, right. Okay, thank you. You are alert. I missed it. I missed it. Thank you so much. 5 and 6 will be there. Correct. 5 and 6 will be there. Thank you so much. So we have represented this. So once we have represented this, we now will write the domain. Domain is consisting of all the first place elements, right? So that is, this is not needed, this comma, so this bracket is not needed. We'll be getting 2, then we can have 3, and then we can have 4, we can have 5. That means all the elements of domain in set A are in the domain. And then range means all those elements which are having some relative in the set A. That is second place element. So 3 is coming, 7 is coming, 3 coming, 7 coming, 6 coming, 10 coming. All are coming. So here 3, 6, 7, 10. All are in the range. And in fact, if you write the codomain, to write it, you do not think much. It is the right hand side set. So this is what we get. This is what we get as our answer, right? But at the same time, please try to make sure one more thing, that we have a notation for writing a relation. We write R, right? Then this arrowhead, that A will be having arrowhead in between, and then B relation. If we want to write like this, you have to write, and there should be arrow from A to B. So this is the notation we use for writing the relation. This is a relation from A to B, and the criteria here we have defined is this. So tomorrow somebody might write this particular relation in this particular way also. So please see this, how we can represent instead of giving the question the way we have represent. We can reduce the task. I can write R equals this x comma y such that, right, such that here we'll tell the criteria. X is relatively prime to y, right? Now you see we close the bracket here because when we talk about this particular statement, so automatically we held that the first element x is taken from A and y is taken from B, the way we mentioned that R is a relation from A to B. So it is, of course, not very necessary to mention that x and y belongs to A and B once you fix that R is a relation from A to B. Am I clear, Swarnav? Okay. So now I'll be taking some more problems, right? I'll be taking some more problems by giving more conditions. Let us first try with them. Then I'll be going for some other problems. Of course, I'll not be able to start it today in this period, those problems. So first we'll discuss the other important problems where we'll be defining a relation like this. Question number three. Question number three. Now you see what I'd like to consider. I'd like to consider a set A. Capital A is the set, and here I'd like to consider elements 1, comma 2, comma 3, comma dot dot dot, comma 14. So these are the elements. We have the elements 1, 2, 3, 2, 1, 2, 3, 4, 5 up to 14. And and remember, this time I would like to consider a relation R, right? Relation R. How will we define it? Just see the criteria. X comma y will be related if x comma y will be related if y is equal to 3x minus 1, right? And x and y are taken from sets A. So here, how will I mention this? Be a relation, be a relation on A. See the difference. Earlier we have written on A to B, but whenever we write simply a relation on A, it means it is a relation from A to A itself. That means this time domain is also A. Sorry, left side set is also A. Right side set is also A. Same set. So this is what the very important point you should remember. Now, as we are doing the problem of its type first time, so I'm doing it with the help of again a figure, right? So that figure will give us a good idea. So this is the set, another set is here, another set means this time both the sets are same, both the sets are same here, both are A only. So let us name them. This is the set A, and then this is the set again A, right? Now the elements of A you write. Now the elements of the set A will write here 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now place is not there. Anyway, I know that the other elements will be of no use, so I write it here 11 and then 12, 13, 14. So I have written the elements here. And then in this side also I have to write the elements. Right, so here purposely I have to write those elements which will be related here. I already have. Okay, I haven't seen it. Now problem will be there. So better let us make the set little bigger. Otherwise, we will not be able to accommodate. I think this big will be sufficient enough. So now I'll have to write the elements here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 15 is not only up to 14. So we have written these elements. Right? Okay. Now what next you have to see? You have to now see one thing you should always be sure when you write that it is a relation from A to A, it means X is also taken from here, Y is also taken from the same set, right? So both should belong to that. Now, if by chance you consider this as the value of X, this one, suppose you would like to consider the value of X to be this one. This is the x. Okay. And now if you put this x in this relation, what will be the y? 3 into 1 minus 1. So how much it is? 3 into 1 minus 1 will give you 2. It means whenever x you consider as 1, y is 2. So that tells you that 1 is related to the element 2 of this set. Okay. Now you pick 2 and try that same thing. If you put this time 2 here in place of x, it is 3 times 2 minus 1. How much? 6 minus 1, that is 5. That means moment you take 2, the element 2 will generate y equal to 5. That means this 2 will be related to 5. Then in the similar way, your 3 will be related to whom? Your 3 will be related to 3 3 are 9 minus 1, that is 8. Next, your element will be related to whom? That you again decide. 4 you take. 4 3 are 12, 12 minus 1 is 11. That means 4 will be related to 11. Very nice. Now, again you see 5 you put. 5 3s are 15. 15 minus 1 will give you 14. That means 5 will be related to 14. Okay. Now you try to again proceed further. Suppose this time you want to consider, because lot of elements are left out. So I want to consider x equal to 6. Then what will be y? 3 times 6 minus 1, that gives you 18 minus 1, 17. But very unfortunately, this 17 does not belong to A. Meaning is that as you do not get 17 in the other side set, this element cannot be said to be related to any element in the right hand side set. In fact, these none of the elements will be related to the right hand side set. Yes, Swarnab, it is clear to you. I do hope that you are clear, but still, I am asking you as a part of my explanation. Should I proceed further? Yes. So now you see from here, once you write, you will find. Sorry, I'm trying to draw this. This particular shape, right? This particular shape is going to represent what? It is going to represent the domain of the whole relation. Domain of the whole relation, right? And the range, again, it is unfortunate or maybe fortunate. I have to write, I cannot write a regular set like this. I have to write it like this, right? So these are the elements, right? Looking like very different animal type of things. So whatever it is, no one can help you. This is the range. And the whole set, it is the codomain. So once you are given a question like this, your questions will be what? First question, you write the relation in the roster form. Roster form. So roster form is ready now. How you can write? It is 1 comma 2. Then 2 is related to 5. Then 3 is related to 7. Sorry, 8. Then 4 is related to 11. And 5 is related to 14. So like this you have written. And then the next part of the question can be what? You write a domain. So domain already you got, it is 1, 2, 3, 4, 5. Next maybe you are asked to write what is range. So range is what? It is 2, 5, 8, 11, and 14. You may be asked also to write what is codomain. Sorry, it is 2, it is 3, it is 4. Codomain. So codomain is the set A itself, not B, is set A. So this is what the question is. It seems a bigger question, but it's not actually. So this is what we did for this question. Yes, one of. If you tell one more question query, I'll discuss and then I'll sign off today. Any questions you want to arise here?
No, sir.
Okay, thank you so much. The last question I am going for, the last question of today's question number 4. Just to give a different way of representations, different way of representations, right? So this time, what exactly I am going to consider is I want to consider the set A where I'll define the relation as the set N. Set N means natural number, set of natural number. And then I would like to refer to the relation. The relation R, how I would define is this x, sorry, x comma 3x plus 2 such that, right, 3x plus 2 such that x less than 5, x less than 5. And here, as we have already mentioned that it is a relation, this is a relation on A. So it is needless to mention that we have taken this x from A, or else we can write it like this also. A means an x value, natural number. Okay, very nice. This time, what is the change? Because of this change, actually, I have brought this question. There is nothing, no such intentions. You see, earlier we had here written x comma y, and we had a relation written here in this part. But this time, this y has been replaced by 3x plus 2. So what happens? Actually, we have modified. Instead of writing the relation like x comma y such that y equal to 3x plus 2 and x less than 5, we have reduced it in this way. So you should understand that this time y, this value has been directly replaced. So after you realize this, then there is nothing to worry about. See, it is very, very clear. In the left side, even if you have considered set A, that is natural number here, right? And then right side also, because looking at this set, sometimes somebody gets scared that natural number is an infinite set. So why and how will be writing the elements, right? How will be writing the elements? But here, once you check, even if it is natural number, infinite set, right? But it will not create a problem. Why it will not create a problem? There is a reason, because if you observe clearly, I have a restriction. The value of x I should continue is up to 4, right? We should not take 5 because x must be less than 5, right? So here, for our convenience, I'll write not only up to 5, some elements I'll write, so that we can show that these are the elements which are left out now in the whole set here, right? So we can write some dots here because this is infinite representation. Similarly, in the right hand side set also, you write some of the elements which you expect to get related with that. You need not write all those elements. So here I will not go for typing this. I'll write manually the elements which are part of right hand side set n, right? So the relation I define is r. Now you see again, if you give the input, that is x equal to 1, what will be the value of y this time? It is 3 times 2 plus 2. So 6 plus 2, 8. That means this one is going to be related to some element here, which is 8. See, I did not write the other elements. I'll write afterwards. Now, if you put x equal to 2, you can do all these things or I committed a mistake. Sorry, it should be one. Sorry, I'm very sorry. It is three. It's five, not eight. Five. Acha, for two only it will be eight. If I write two, then only eight. This element two is related to some element eight. It will be related to it. In the similar way, you can easily identify that 3 can be related to 3 can be related, 3 threes are 9, 9 plus 2, 11. Then 4 you can take now. You have only a chance to consider 4. 5 you cannot take. So 4 threes are 12. 12 plus 2, 14. Now there is no question of taking this 5, this 6 because they have already restricted you. So after doing this, if you would like to now write what is the relation in roster form, so easily you can write. Of course, the figure is not a very important part here because they did not say in the relation to draw it, but just to explain it, I have taken the help of this. Without figure also you can write this. This is in the roster form. Then if I ask you what is the domain of the relation, it is obviously 1, 2, 3, 4. And if I ask you what is the range of the relation, so it is consisting of 5, 8, 11, 14. And what is the codomain? Codomain is a complete natural number. Right here, of course, 1, 2, 3, 4, 5, 5 already written, 6, 7, etc. You can write anywhere, just floating anywhere. 8, 9 is not there, 10 is not there, 11, 12 is not there, 13 is not there. At least up to here. So this is the representation. Yes, you have understood. Okay, one I think very important part I did not tell you, so I'll go back to this figure before, and then I'll tell you immediately, and then I'll sign off. Actually, it will be otherwise left, and it will not be completed as a complete explanation. I think I have skipped. Suddenly, I'm remembering this. That means I think I did not talk about the image and the pre-image. Now, for that, just a simple concept. 1 comma 2, you can see 1 is related to 2. This one is called the pre-image of 2. This 2 is called the image of 1. So actually here if I draw the figure, elements which are related from the right hand side, this element 2, right? 2 is related to whom? 2 is related to element 1 in the right side. That means it has a relative. It is not kept related to anything. It is not like that. It has a relative in the say left side A. So it is known as image of 1. We call it image of 1 under the relation R, right? And similarly, this one is known as the pre-image. It is called the pre-image of 2, right? So this particular statement you try to remember. And in fact, images are belonging to range and pre-images are belonging to domain. That means, in one word, range is actually the set of all images, and domain is the set of all pre-images. So today with this, I'll wind up. We'll see you in the next day. So if you have anything to ask, you can ask. Otherwise, we'll say bye bye. So Swanaf, today I'll be leaving, and I have explained you all terms of relations. What is explained in the book of class 11. So second exercise is homework for you. Right, the first one you might have done yesterday, day before yesterday. Sort of done. So today homework is next one. So bye bye. I'm signing out. Okay.